What you mean? Ooh-wee. That lot is great. Hey, I put that paper over there.
I know. I was gonna say.
Whatever you don't use, just slide underneath your desk, okay?
I really hope you don't.
Not like, this is not economical. I don't gotta watch nothing. Yeah, why you in my salad? Why you going all of my life like that?
Guys, want to pull out the tools for learning? They should be out on your desk. Don't write the standard down, but this is where we're starting the class period today, okay? Your phone should be placed away, your earbuds should be put away, all things away, except for your tools for learning.
Yeah.
know what? You come out. Come on, let me say something. You watch your tongue when you talk, you know? And don't play with me. Because I told you not to. And because I ain't got to play with it. And I ain't got to play with it. I am. Because I won't. I told you. I stayed in my head. Okay. Okay. Don't sit down. Why you gonna play toy? Okay. The whole play box, okay? This whole toy box. Young people, we are progressing with our lesson today. Yesterday was a quiz. There are several of you that did not have the opportunity to take the quiz because you were absent. You will work out with me how you will make up that quiz. I will be available after school tomorrow doing a tutorial. We also have I think we have a Wednesday next Wednesday. Now, that would bring you to one day past the required 1 week, like you have 1 school week to take care of a missing quiz. You understand what I'm saying? So it would be better for you to take care of it tomorrow in tutorial. Or make sure you're not absent on quiz day. All right? Okay. Phones are put away, earbuds are put away, phones are put away, earbuds are put away, snaps are put away. Thank you. Alexis, you still have your earbuds in. Everybody should have something to write with and write on their desk. Everybody should have something to write with and write on their desk. Yeah,
That one, actually, just. This was, I'm not what you are. I see. See what you got. In your ear. Look, I'm just making sure.
All right, party people. Today's lesson is derived from the following standards. All right. ASSE 2 states, use the structure of an expression to identify ways to rewrite it. FIF 8A states, use the process of factoring and completing the square in a quadratic function to show zeros, extreme values, and symmetry of the graph and interpret these in terms of a context. All right. Today's objective is as follows. Today's date is January 12th. Go ahead and write it down on your paper. You guys will be learning how to solve quadratic equations by factoring. Solve quadratic equations by factoring. May I proceed? Bless the teacher. I was clearly stuck, baby. May I proceed? Thank you for catching that for me. I can go? All right, let's go. All right, young people. I may be using the following terms throughout today's lesson: factored form or factoring and FOIL method. All right, you don't have to write these down because we've already been talking about them, as a matter of fact, when we were multiplying our complex binomials. All right, may I proceed? All right. So young people, just a quick refresher about FOIL. I mean, we literally just did this when we multiplied and divided our complex numbers. But the FOIL method is simply double distribution. FOIL stands for first, outer, inner, last, where you multiply the two first terms. Okay, first terms, then the outer terms, inner terms, then the last terms. All right, it's really double distribution, where every number or every term in the first set of parentheses is multiplied by every term in the second set of parentheses. Everything is being multiplied by everything. All right. But the piece de resistance is the zero product property. This is what we're going to be using today to solve quadratic equations. All right. And the zero product property simply says this. Once you factor a quadratic, you'll have two factors, right? Naturally, you factored it. Once you factor them, you take each factor and set it equal to 0 to solve for the unknown variable. That's all the zero product property is saying. Formally, it states, you can see it. All right, for any real numbers, A and B, if A times B equals 0, all right, either A is equal to 0 or B is equal to 0, or both, okay? Or both A and B can be equal to 0 at the same time, all right? And that is certainly the case when we talk about quadratic functions, all right? And there is an example, but I'm going to move on to our first example here, where we'll be using the zero product property to solve the given expression. We have 9y squared plus 3y equals 0. Write that down on your paper, please. 9y squared plus 3y equals 0. Now, the first method that we're going to use to factor or solve this expression is by factoring out the greatest common factor. All right. So look at 9y squared and 3y. Look at them very carefully. Look at the coefficient first. Look at the 9 and the 3. Can 9 and 3 be divided by the same value evenly? What value is that? Okay. That's the greatest common factor between 9 and 3, right? Okay. So when you factor it out, it'll look like this. Let me change my color. So I'm factoring out a 3 from the 9 and the 3. Now look at the variable portion of the expression, the variable portion. So I have a y squared here and I have a y. What can I factor out between a y squared and a y? Okay, just one y. Remember, the lowest number of variables that you have is what you're going to be able to factor out. Okay, so I'm factoring out 1y. So if I'm factoring out 3y, what's going to be left behind inside of the parentheses? Well, remember, when you factor something out, it's like dividing each term by what you factored out. Okay, and 9y squared divided by 3y is what?
3y.
Just 3y. Because remember, when I multiply this back through, 3y times 3y has to be equal to 9y squared, right? Okay. Now look at the second portion. We have 3y divided by 3y. What am I left behind with? I'm left behind with 1. Very good. Miracle, right? Boom. There's my 1. So when I multiply this back throughout, boom, I'll get my original expression back. And don't forget to set it equal to 0. Okay? So now I have two factors. I have the factor 3y times the factor 3y plus 1 is set equal to 0. Now, according to the zero product property, I now will take each of these factors, 3y, set it equal to 0, and 3y plus 1, set it equal to 0. Because the zero product property said I could. You should be writing this down. And once you set it equal to 0, y'all, we're back in middle school now, right? We're back in middle school. And we're going to solve for the unknown variable. 3y equals 0. I got to get y by itself. That says 3 times y. I undo it by dividing by 3, right? And get that y is equal to 0. Over here, what's my first step? We're back in middle school. Y'all did this already. Absolutely, Chris. And I get that 3y equals -1, right? So now I'm going to divide everything by 3. Everything by 3. And I get -1 over 3. Bam. These are my two answers. Bam. I'm done. This should look real familiar from first semester, yeah? Okay? And even Algebra 1 or before in middle school when y'all were doing this. May I proceed? Okay. All righty. Let us proceed. Oh, and I didn't say this before, but I'm going to say it now. Guys, you will use the method of factoring out the GCF when you have an expression that only has 2 terms, and one of them, and well, both of them. Baby, why are you raising your hand? You had a question? All right, well, chill out, because that kind of sets off my meter when I see kids' hands raised in the air and waving like you just don't care. Okay? All right. All right, so like I was saying, you use factoring out the GCF when you only have 2 terms, okay? And more specifically, the 2 terms do not include the constant of a quadratic. So notice both of these have, if your phone is beeping, can you put your phone on silent or shake? Thank you. Both of these terms have a variable, okay? This is when you will use the GCF method of factoring. Is that clear? Thank you. All right, so look at this one. Same sort of situation, right? I have 5a squared minus 20a equals 0. Notice I only have 2 terms, and it does not include a constant value, right? Right, Jamari? Pick up your pen up, baby. Write this down. So I'm looking at 5a squared. I'm looking at -20a, and I'm like, okay, what can I factor from both of these terms? Okay, a 5. I can't factor out a 5. What else can I factor out? 5a. Absolutely. I can factor out evenly a 5a from each of these terms. Okay, so what's left behind? Well, remember, it's like dividing everything by 5a, and whatever's left, that's what you put inside the parentheses, right? Okay. So these 5s cancel out. This a cancels out with one of these a's, and I'm left with 1a on the inside, right? Yeah. What am I left with -20a divided by 5a? I didn't hear you, baby. Negative who? You're dividing. Do -20 divided by 5 in your calculator, Jason. I hear y'all, you're right. Okay, be careful. Don't subtract where this line right here means division. Okay? Don't be confused with this. So I'm left with -4 on the inside of the parentheses, and that's still set equal to 0. All right, remember, after you factor your values out, you have to be able to get back to the original. Look at this, Jason. 5a times a would give me 5a squared, and 5a times -4 would give me -20a. Do you see? Okay, I'm going to erase that. I just wanted to show you. All right, now that I have my two factors, what do? Set them equal to what? So 5a equals 0, and a minus 4 equals 0. How we doing? Jamari? I need you to listen with your eyes open, baby, okay? We're back in middle school. I'm going to divide both sides by 5 here to solve for a. A equals 0. And I'm going to add 4 to both sides over here. A equals 4. Okay, these are my two answers. May I proceed? Anybody object to me proceeding? How y'all feeling? No problem, baby. I'll wait. Thank you for letting me know. All right, sugar baby. Anybody else? Okay, I'll wait. Elijah, I'm waiting on you, babe. Why you ain't say nothing? Don't make me come over there, yeah. All right. For what? You're welcome. All right, party people, on your own. Let's knock it on out. On your own. I'll give you 2 minutes. Hey, Google, set a timer for 2 minutes. All right. What do you think the answer is? Did you factor completely? You got to factor first and then set it equal to 0. Did you do that? Who said it's A? Marion, that's you? Let me see if I can go back. Yeah.
Looks like I only had 2 people maybe did drive.
You said what?
I only had 2 people did drive.
They did not? Okay. All right. That's good.
Come on, give it a
All
try.
right, so now 3. So remember, you can't divide 3 into 4 easily, right? And you got the right idea. That's what's going to be left. After you pull 3 off, after you pull 4 off as well.
That's what you see.
Okay? And you see what you divided by? That's what you factored out. Does that make sense? Right, so you factored out not only just a 4, but also a what? There you go. Okay? So write that on the house, put X reference. So put 4X on the outside of the parentheses. Does that make sense? So what's going to be left inside? 3. Okay? And then with these 4's gone, and this X going to one of these, it's going to be 3 minus X. Make sense? All right. If you said that D was the correct answer, you're absolutely right. Let's see why, okay? Anybody need me to look at their paper? Anybody else? Yes. You factor out a -4. Don't factor out a -4. It's perfectly sufficient to fill out just a regular 4. Okay, so this is erase the 4. All the time I would tell you to do that, I'm sorry, is if your leading coefficient was -4. As if put a +4. All right. All right, good job. Erase it there. So you are in fact factoring out a 4x. So that means you're dividing everything by 4x, right? The x and x. All right, so erase this inside here because you got a whole new situation. Okay? So what is 12x divided by 4x? Just 3, there you go. All right? And so now I want to continue and think about what is -4x squared divided by 4x. Okay? All right, anybody else need help? Need me to come to you? Don't be bashful. All right. Dorian, you all right? All right, y'all. So I am factoring out, what does 12x and -4x squared have in common? If you said 4x, you're absolutely correct. Okay? Factoring out 4x. I noticed some of you guys wanted to pull out a -4x. That's cool. You still end up with the same answer, but you're making things muddy for you. Okay? You're making things muddy and more difficult than they have to be. I'm about to show you how to handle this. So if we're factoring out a 4x, that means I'm dividing everything by 4x, right? Let's see what's left behind. 12x divided by 4x, David told me it's 3, and he's right. Okay? And then -4x squared divided by 4x. Notice this x cancels out with one of these, and this 4 cancels out with this 4, right? So what am I left with? -1x. Okay, minus 1x inside the parentheses. 3 minus x anyway. And that's still set equal to 0. Do you have what I have? If you didn't, do you understand why you should have? Okay, any questions or concerns right now? Marion, how you feeling? Okay, good. So now I'm going to take each of these factors and set them equal to 0 separately. Okay. Same as before. It just looks a little weird because they kind of switch some stuff around, but it doesn't matter. We still follow the same procedure. So on this side, x is equal to 0. On this side, I'm going to subtract 3 from both sides. Okay. The rules don't change just because it looks a little weird. Okay, the rules do not change. And so now I have negative x is equal to -3, right? And now to get rid of that negative in front of the x, remember that's a -1, right? So I'm going to divide both sides by -1. Right? So now I have that x is equal to a positive 3. So in fact, like Chris told us, the answer is D. 3 and 0. Okay? 3 and 0. All right? Questions or concerns? Can I go? All right. Hey, here's a regular, degular, schmegula quadratic function, right? And young people, let me review something with y'all. When you're asked to solve a quadratic, what are they actually asking you, right? Does anybody remember from last semester? What is the solution to a quadratic equation? What is that telling you? What is it telling you? Remember, do you guys remember when we were graphing these? Maybe I need to graph one to jog your memory. Hold on. So we have x squared plus, what was it? (13x plus 42). Look at that. That's the graph. That's the graph. Young people, when you're asked to solve a quadratic, okay, what they're asking you really is where does this quadratic cross the x-axis? When you're asked to solve a quadratic, they're asking you where a quadratic crosses the x-axis. Okay, yeah, I know because I taught you. Don't be looking at me. Y'all remember me saying that last semester now? I will fight the whole class, I promise. Even my new students. Because I know y'all teachers taught y'all too. Tiffany, don't be looking away. I see you, Janiyah. Anyway, again, they're asking you, when they ask you to solve a quadratic, they're asking you where that quadratic crosses the x-axis. But more specifically, young people, why the x-axis? Well, notice that the quadratic crosses here and here, right? Can y'all see that? What are those coordinates? What are those coordinates? Let's see. What's the coordinate here? -7, 0, right? And what's the other coordinate, Jamari? Somebody help him out. What's the other coordinate? -6, 0. What do both of those points have in common? 0. Yeah, they're both negative, but more specifically, they both have a y value that's what? That's 0. Let me go back to the PowerPoint, y'all. Originally, this is what this equation looked like. It originally looked like this. Y equals x squared plus 13x plus 42. But when they asked you to solve it, okay, when they asked you to solve it, they're asking you, what is the value of x when y is equal to 0? So they went in and they just plugged in the 0 for y for you, right? But I need y'all to understand what's going on here. I don't want y'all just solving and factoring just because. I need y'all to understand what you're doing, okay? Okay, but they don't leave with that 0 in the front. They put it on the end, okay? They switched it around. Symmetric property. They have x squared plus 13x plus 42 equals 0. Do you all understand what's going on here? Is it coming back to you? All right. So now, We got to solve by factoring. I'm about to factor this thing, y'all, okay? And because my leading coefficient on x squared is 1, this is really, really, really simple, okay? I need to think of two numbers that multiply together to give me 42, but add together to give me 13, okay? Now, some of us are able to do this in our head. Be like, oh, I got it. This times this, boom, I'm ready to factor. For those of you who don't have it, that's okay. Okay, and notice everything is positive, so I don't have to think about any negative values, okay? So I'm only going to be focusing on the positive values for the factors of 42. So let's go. I got 1 and 42. Does 1 plus 42 equal 13? I'm going to keep going then, right? I got 2 and 21. I know 2 times 21 is 42, but is 2 plus 21 equal to 13? No, I'm going to keep going. 3 times something. 3 times what equals 42? Somebody help me. Say what, baby? 14. Thank you, sugar. 3 times 14 is 42, but is 3 plus 14 equal to 13? Remember, I'm looking for two numbers that multiply together to give me 42, but add together to give me what? 13. All right, let me keep going. 4, no, 5, no, 6. Okay. 6 times 7. Uh-oh. 6 times 7 is 42, and 6 plus 7 equals what? So here go my factors, y'all. Okay, so this is what I do. I have x plus 6 times x plus 7 equals 0. All right, just like with the previous problems, once you have your factors, you take each of them and set them equal to what? So I have x plus 6 equals 0. And I have x plus 7 equals 0. Back in middle school, I'm subtracting 6 from both sides. I have x equals negative 6 over here. Over here, I'm subtracting 7 from both sides. X equals negative 7. Boom. I just solved it. Now, I showed y'all the answer already on the graph, didn't I? Didn't I? I'm going to go back to it real quick. Look, I showed y'all what this thing was going to look like. Showed y'all that it crosses the x-axis where and where? At negative 6 and negative 7. Then we see that, but you're not going to have access to no decimals graphing, are you? And you need to be able to determine, your solution, bless the teacher, all right, algebraically, like we just said. Any questions or concerns? All right. May I proceed? David, are you having trouble seeing? Yeah. You took a picture. You just want to capture it for your records? All right, baby. You know I'm recording this. You know it's on the class website, right? Bless the children. I'll remind you about it before you leave, okay? May I proceed? David, you still right now? Let me know when you're done, please. All right. All right, look at this one. Okay. Here we have x squared minus 12x plus 35 equals 0. All right, so you see how my middle term is negative 12x? So that means I have to consider the negative aspect of the factors of 35, right? So again, my leading coefficient on x squared is 1, so it's super easy. I need two numbers that multiply together to give me positive 35, but also add together to give me a negative 12. Let's see. And if you're not writing your chart down, y'all, and you come up to me telling me something, I don't understand, I can't get my answer, I don't want to talk to you. I'm showing you a surefire way of getting to the answer every time on your own. If you're not going to take the steps that I give you, shame on you. There's no wonder why you don't understand, because you're not doing what I tell you to do. All right? All right. So 1 times 35 is 35, but that's positive, right? Remember, my middle term is negative, so I have to consider the negative aspects of positive 35. So just like positive 1 times 35 times positive 35 is a positive 35, also is negative 1 times a negative 35. But either way, 1 plus 35 is not negative 12. And negative 1 plus negative 35 is not negative 12. So I'm pressing forward, right? All right. 2 doesn't go, 3 doesn't go, 4 doesn't go, 5 does. 5 times 7 is 35. But 5 plus 7 gives me a positive 12, doesn't it? Right? I got to keep going. Negative 5 times negative 7. Looky there. What's negative 5 plus negative 7, y'all? Negative 12. Boom. These are my factors. Do you see? Okay. So when I write it out, I have x minus 5 times x minus 7 equals 0. Now what do I do? Miracle is not playing with y'all today. We're back in middle school. Back in middle school, right? X equals 5. What do I do over here? Yep. And x is equal to 7. If I graphed this quadratic, I would expect it to cross the x-axis at positive 5 and positive 7, period. How we doing? I'm gonna graph it just for good measure. Can I graph it real quick?
Got that right, Ms. B.
You got it right?
You got that right.
Don't do that.
Move on to the next one.
I want to graph. You know, this is for me, not for you, right? I'm just up here having fun. Y'all, Chris said, hey, lady, don't graph anything. Can we just finish the lesson? No, I want to graph. Bam. What did we say it was going to cross at, y'all? Positive 5 and positive 7. Y'all with it? All right. See, that wasn't so bad, Chris.
Was it necessary?
Yes, it was. Do this one on your own, y'all. Oh, no, not on your own. Y'all, look at this. This says x squared minus 11x equals negative 28, right? Yo, all the problems we've been doing all day have been set equal to what? Have been set equal to 0. Y'all, when it's not set equal to 0, you need to make it set equal to 0. Clear? So right now, this expression is set equal to negative 28. I need to turn that negative 28 to a what? To a 0. But how do I do it? Add a 28. Now, I just can't erase negative 28 and just slap a 0 on there, right? Right? Y'all hear y'all. Y'all saying I need to add 28 right here, right? And add 28 over here, correct? Right? Okay, good job. So I'm left with x squared minus 11x plus 28 equals, now typically we would just cancel those out, right? But I need to write the numerical representation of nothing, which is what? 0 is the numerical representation of nothing. Now I got me a problem to work out. I need two numbers that multiply together to give me a positive 28, but add together to give me a negative 11, Dorian. Need to splash some water on your face? I think you and Elijah do. Elijah, you all right? I don't know. Can I make a chart? Are y'all good? You got your answer? Alexis?
Me?
Yeah, you.
Nah,
Okay.
I'm ready.
You waiting on what? I'm waiting on you. Write something down. Figure it out. I'm about to make my factor chart. Somebody help me make this factor chart. What you got, Chris? Mm-hmm. Uh-huh. 2 and 14.
2 and 14, negative 2, negative 14.
Uh-huh. 3, no. Mm-hmm. So which of my factors up here add together to give me negative 11? Uh-huh. Boom. What's hard about it, y'all? How we feeling? Mm-hmm. So I have x minus 4 equals 0. And I have x minus 7 equals 0. Back in middle school, I'm adding 4 to both sides. I get that x equals 4. I'm adding 7 to both sides. X is equal to 7. Miracle, I love your shoes. Guess what? The CEO of Converse went to my alma mater and I met him. Like, we took a picture and everything. I'm so proud. Oh, I'm a rattler too. You know about them rattlers, don't you, Dora? I know you do. May I proceed? Don't be hating, Jamari. I see you. I see you over there hating. I can smell it. Dang. Haters over here hating. All right, y'all, knock this one out on your own, please. Now notice all of the signs are negative. All of the signs are negative, right? So I need two numbers that multiply together to give me a negative 15, okay? But add together to give me my middle term of negative 2. Be careful when you're making your chart, okay? I'll start you off. 1 and negative 15, not 1 and 15. Oh, no, no, no. My 15 is negative, right? And I also have negative 1 and positive 15. Only one of the numbers can be negative to generate a negative product, right? Okay, what are the other factors? Okay, 3 and what? 3 and negative 5, very good. And what's my other ones? What's the other one? 3 and negative 5, what's the next one? Thank you. Now, of these factors, which of them add together to give me my middle term of negative 2? Negative 5 and 3, very good. So I have x plus 3 times x minus 5 equals 0, and everything else is exactly the same. Okay, y'all? So I have x plus 3 equals 0, and I have x minus 5 equals 0. Subtract 3 from both sides. I get x equals negative 3. Add 5 to both sides. I get x equals positive 5. Boom, done. How are we feeling? Okay. May I proceed? No? All right. Hey, we through, y'all. Log into Delta Math. Pull out your devices. Pull out your devices. Yeah, take the orange pass. Take the green pass.